So we're now going to transition from large collections of still images to video. And our next presenter is Jaimes from Yahoo, and he'll be talking about deep reasoning for video content understanding at Yahoo.
Thanks, Serge. So I go by Jaimes as well. So can we get the slides up, please?
Kilter.
Great.
I'm sorry, Kilter.
So the first thing to say is computer vision is hard. You know, we've seen a lot of stuff going on, and just to show you an example, how many people see things moving? Raise your hand. Oh, great. I can hypnotize the entire audience now and say whatever I want. So obviously there's no motion. It's all in your head. So it's just an example. And what I want to say with that image is essentially that a lot of the processing, a lot of the computer vision processing that we make as humans is actually in our head. It's not just in the signal, it's in the processing that we actually do, right? And so because of that, the approach that I like to take in any computer vision problem is what I call a human-centered approach. And basically what that means is a very strong focus on more than one area. So it's not just pixels, it's not just computer vision, it's understanding user experience, understanding data analysis, what I call human aspects, and really working at the intersection of those three. And that's where the real machine learning work actually happens. Sorry, the timer's not working, by the way. So that means I have an extra 2 minutes. Great, lucky me. So how do we do this? And you know, what are the main tasks? So one is understanding the users. Second one is understanding the content, understanding how they go together, and then creating new algorithms and new applications. And this through large-scale data analysis and machine learning. And the reason that these dimensions are important is because, as has been said before today, most of computer vision techniques don't work perfectly all of the time. So we need to really understand how they can be applied in a specific context, and that depends on the content and the users, how the users will use it, the design, the application, and so on and so forth. So, you know, recognizing things in baseball videos is not the same as in music videos, or as in any other kinds of sports videos or surveillance, right? So the technologies might be similar, but the actual application really varies significantly. So from that point of view, everything we do is really a cycle where the user has to be at the center of it all. And we start with either data analysis, design, or hypotheses. And that's how we kind of develop it. And the basic idea is that we cycle between these three areas within a specific context. And the more that we do that, the closer we get to the user. And that's how we innovate and get to a point where we make a difference for users. So what I'll do is I'm going to do something really risky, which is I'm going to show some demos. Hopefully some of them will work. I'm not going to show all of them, but these are some of the areas in which we're doing some work. I'm not going to show anything adult because I think everybody knows what that is. But in essence, you know, I think there are kind of two main areas. One deals with algorithms, and the other one deals with insights. And it's really important to do both because, as I said before, you need to understand how users are using the content, how they're viewing, and how they go together, right? So what is the main computer vision task? It's basically, you know, given an image or a video, recognize objects, actions, or events. So in essence, that is the core technology, right, that most of us are working on. But I would say that that's not enough. In most cases, that's definitely not enough. And, you know, from this, what we usually get is labels, right? Which, you know, historically, a lot of people have referred to this as image understanding and video understanding. I don't like that term because we're not really understanding anything. We're just labeling. It's not the same. Labeling and understanding are not the same. And I'll say a little bit more about that. So just some examples of stuff. So we're doing things like celebrity tagging. So the basic idea is that we want to find images of celebrities and find not only images of celebrities, but find the best images, the best quality images, and often the most representative images. So for a single celebrity, we want to find one celebrity who is, one image that's the best one for that particular celebrity. So this is an example of something that's done automatically from a very large collection. And if you look carefully, you'll notice that there are a lot of issues or possible issues in doing this automatically, which are very subtle, that are really difficult to deal with. So we want to have the highest quality images, right? So things like the one at the bottom where you have beer mugs in the guy's face, that's not really acceptable, and it's very hard to detect automatically. Or if you look at Sarkozy at the top, I think, ironically, he's next to Bush. You know, the way he's using his hands, for him, that's actually a pretty good portrait because he uses his hands often, right? But in other cases, you don't want to have a hand in front of the face. You want to make sure the eyes are open, the lighting is good. So here's another example of an image where, you know, the quality is maybe not that high. But again, we're looking at a particular set of images, we're picking the best one. And the applications of this are, of course, you know, if you search for a celebrity, for example, you get a little box with a photograph of that celebrity. One of the things that I discovered working on this project is how many celebrities there are. There are thousands and thousands, and when you work at a global scale, of course, you know, it's not just the ones that I know. You know, there are famous people in India, in Africa, in Indonesia, and all these places, and you know, it's a pretty hard task. So obviously, it can't be done fully, can't be done manually. And the other issue is obviously that when you have so many, you have different celebrities with the same name, right? So a lot of interesting challenges. So in relation to that, you know, one of the things that we need to look at, not only in that context, but in general context of image and video, is aesthetics. So all the quality metrics and creativity, finding the most creative and the most interesting project is quite a big challenge. So now I'm going to jump into the demos very quickly. Okay, so this is an example of, you know, just a deep learning framework for annotating video. And what we're doing here is essentially when you take a video and you tag it automatically, all you're left with is a bunch of tags. Now the problem is the tags alone are usually not interesting enough and they're not sufficient to determine what's in the video. So what we're working on is going multiple levels deep into the tag hierarchy and reasoning on top of that classification, right? So I'll show you some examples of what we're doing with this. So in this particular example, we have a number of tags and then how frequent they are at a particular point in time, right? And this gives you, again, some of the ideas on the challenges that we have at the video level. And what I'm saying with this is that individual tags are really not going to be enough for what you need. Here what we do is match videos with ads, again, based on the tags. So basically just to have a reasoning engine on top of the deep learning framework so that this is the best ad for that particular video. And this is also useful for search. So if you search for furniture, you get a video where furniture is more prominent, and so on and so forth. The other area is automatically generating video summaries. So this is one example of that, where this video summary it's a 15-second summary generated fully automatically from the original video, and then a summary animated GIF. And I'm not going to have time to show the live demo of that, but you know, it takes a few seconds to do a full video. So let me just finish then by saying, you know, in terms of image understanding, there are many levels of classification, labeling, and humans do this. We have what we call basic level categories. There are objective, subjective metrics. As an example, there's some work in psychology where they've done studies where they find that human accuracy in recognizing objects varies depending on whether the background and the foreground match. So there's a paper cited there. And what are the biggest challenges? I think one of them is what to index. You know, we have these deep learning frameworks that can easily label stuff, but that's usually not enough. We need to go a level higher. How to match that to user interests is the second one. And the third one is aesthetics and creativity. So thank you very much. Oh, and that's an example of some of the videos that we are able to automatically classify as creative versus non-creative. Thank you.